Hi, we're Team SaniScope.
Municipal-acquired infections can be deadly to patients and cost hospitals in the U.S. between $28 and $45 billion annually. Despite measures to reduce infection transmission, stethoscopes are used by nearly 80% of healthcare professionals, yet often go unsanitized between patient visits.
Current solutions include the use of wipes with harsh chemicals that require the use of PPE, which leads to a lack of compliance and insufficient disinfection.
A new solution to this problem would target all healthcare professionals who use a stethoscope on a daily basis as our potential users, including physicians, med students, and nurses.
So 36.4 million people are admitted to U.S. hospitals every year, and if every single one of their doctors used a SaniCloth to clean their stethoscope, that would translate to a total addressable market of 2.55 million USD. However, only about 80% of physicians actually use a stethoscope, and so if they sanitize their stethoscopes, that's 2.04 million.
Based on user feedback, our device must be efficient and sanitize the region that comes in direct contact with the skin. Therefore, our device recognizes at least 90% of the inputs and sanitizes the full surface area of the chest piece and tubing.
Our insertable solvent sprayer design. Here you can see the inner workings, which includes battery power and electronically activated sprayers.
Here's a piece-by-piece demonstration of our prototype in action. First, the user will insert the stethoscope into the top of the device.
Upon insertion, the IR sensors are triggered. Following a short delay, the pump sends IPA to the 13 sprayer nozzles located in the housing.
Here is a simulation of the fluid dynamics of a flat-tip spraying nozzle, specifically of the pressure of fluid passing through the nozzle. After constructing the full physical prototype, we plan on testing the IR sensor and sprayers in the device to replicate results with multiple sets of nozzles attached to the sensor. We would also like to hand this device off to a physician and ask them to use the device based on the attached signage.
Current solutions offered include covers, machines, and UV light sterilizers. Our device falls into the machine category, but is novel in its orientation of lowering the stethoscope perpendicular to the ground and sanitizing the majority of the stethoscope tubing in addition to the diaphragm and bell.
With a simple, efficient solution, healthcare professionals would now have a way to sanitize their stethoscope between the dozens of patients they use it on.
Our device needs further sprayer functionality testing and user validation. Future thoughts include implementation of LED lights to signal completion and easier access to the battery pack and motor.
For the regulatory pathway, we will build a working prototype, work on a provisional patent, continue validation and verification, file a non-provisional patent, manufacture, market, and implement.
Thanks for watching!